Alrighty, so composition of functions. And we're going to start by just some little baby function notation first. If they give me f of x equals 2x minus 3, and I want f of 5, I'm just going to substitute in 5 everywhere I see an x, right? So 2 times 5 minus 3, so that's 10 minus 3, and that gives me 7, right? It's like super old business, super easy. But I don't always have to evaluate at a value. Sometimes it is an expression. So here I'm going to substitute that in everywhere I see an x. Anytime you ever substitute in anything with more than one term, you make sure you put it in parentheses. So this will be 2 times 5x minus 1 minus 3. Make sure you distribute appropriately. So 10x minus 2 minus 3. That's equal to 10x minus 5. And you're done. Don't go do anything weird like try to solve it because there's nothing to solve. You shouldn't get an x equals or anything like that. Like, that's your answer. Okay? We good? Most of this today will be like, why are we even going back over this? But all right, so then we have composite functions. So sometimes in math, we input a value of x into a function and then use the output to plug into another function. So the output of the first function becomes the input for the second function. When you do that, that is what makes it a composition of functions. Okay, so your output becomes your new input, and then you get another output. So we're going to look at a function machine, right? So here's just a plain old function machine. I put something in, so x goes in. Whatever g is happens to it. And then what comes out is going to be g of x. It's like putting a quarter in a gumball machine and you don't get your quarter back, you get the gumball out, right? Something happens to it. So if I have x that goes in, g of x that comes out, and then my output goes back in, and then I get another output, that is where I get f of g of x. That makes sense for you visual people? What's happening with your little function machines there? And then this is just the same type of thing, just kind of all in one. All right, so it says let g of x equal 3x plus 1, g of 2 equals c. We're going to find g of c. So the first thing I need to find is c. And so if I do g of 2, that is 3 times 2 plus 1, that is 7. So g of 2 equals 7, and g of 2 also equals c. So basically, c is equal to 7. So when I want g of c, that is g of 7, just 3 times 7 plus 1 is 22. Okay. What questions we got? That make sense? We all good? All right, so then we have two different types of notation here. One I like way better than the other. Both of them you read as f of g of x. This one, and you always work from the inside out, so this one to me is a little bit more obvious. So anytime I get this, I like to rewrite it like this. Do you absolutely have to? No, but I think it's a good idea, and I think probably most of us should. And it's not fog, that's not an O, that's not a circle, it's a teeny tiny little circle because it is open and it just represents function notation is all it is. And then in general, compositions are not commutative. So that means like 2 times 3 is the same as 3 times 2. It doesn't matter what order we do it in. But that is not the truth for compositions. It's possible that f of g of x equals g of f of x, but that's not going to happen every single time. So it's definitely not a rule. All right, everybody okay with all that? Questions? All right. So then when we're evaluating them, we first evaluate the inner or the right function. Then we use the output as the input. Okay, again, whole business because we know how to do this. So I've got my f and my g here. So if I want f of g of 3, the first thing I'm going to find is g of 3. So I'm going to substitute it in up there and get 2 times 3 plus 1, which gives me 7. Right? Then f of g of 3, which is what I really want, becomes f of 7, since g of 3 equals 7. And then that's 3 times 7 minus 5, which gives me 16. Any questions about where anything's coming from? All right, then you do B. See, we did f of g of 3 and g of f of 3. Did them in the opposite order, and we did not get the same number. Okay. Any questions at all? All right. So then, let's do f. I'm going to rewrite this as f of 2. Okay, so I'm going to substitute it into f, get something out, and then substitute it back into f. So I'm going to start off with f of 2. Give me 3 times 2 minus 5, which is 1. Then f of 2 will just become f of 1. And then that gives me 3 times 1 minus 5, which is a negative 2. What questions do you have? Anything? This is all business, right? It's not even getting that much more complicated. I mean, it shouldn't get any more complicated than what you did in Algebra 2. Might even be a little bit easier. All right, so on the next one, we're going to use the same equations. So they're not here. We're going to need to rewrite them so that we don't have to flip. F of x equals 3x minus 5. And g of x equals 2x plus 1. Okay. So we're going to find, so it says when working with compositions of functions, the input does not necessarily need to be a numeric value. We can also simplify. So this f of g of x, I'm going to take what g of x is. G of x is 2x plus 1. Substitute it into f of x everywhere I see an x. So I need parentheses, 2x plus 1. And then don't forget the minus 5 there, right? Then just simplify it. 6x plus 3 minus 5 is going to give me 6x minus 2. Okay, any questions about that? All right, then you do B. Any questions? We got this piece of cake, right? All right, so you do A and B on the next part and stop. Just do A and B.
Do we agree with 50 and negative 11? Right? Just got to make sure we don't make, ridiculous mistakes with our numbers. Okay, so then C is going to be K of M of X. Okay, so this is M of X. I'm going to substitute it in with 3x plus 2 squared plus 4 times 3x plus 2 plus 5. Now, when you simplify this, which is a very basic algebra concept, when you square this, this does not become 9x squared plus 4. And if you think it does, you belong in math jail. All right, so simplify that. Make sure you multiply that out correctly in whatever form or fashion you choose to do that, as long as it's legal. But I'll give you a minute to simplify that down. While you're doing that, I'm going to pass out the second page of notes. I know there's another example on here, and we're going to do it. I'm just going to use this time. Maybe phone a friend if you're not sure what to do. And that is what you should get. When you square this, legally, this is what you get. Square a binomial, it's going to become a trinomial. You're going to have to FOIL it, know the rule, just whatever. I mean, there's different ways to go about it. I don't care how you do it, as long as you know how to do it, whatever makes the most sense to you. Any questions at all? All right, let's look at this last one. The figure shows the graph of the function f. So f is the graph, and this is g. Always make sure you know what you're looking at. Okay? This is still on the same page we were just on. The function h is defined by this. H of x equals g of f of x. Then I want h of 6. So h of 6 would have to be g of f of 6. That makes sense from what they told me? They gave me this right here. So then where do I figure out f of 6 from? The graph. And what is f of 6? 1. So this is really just going to be g of 1. Do I go back to the graph then? No. I use my equation. So this is going to be 1.2 times 1 cubed minus 4.7 times 1 plus 9.62. And yes, this has decimals in it. This would be a non-calculator question. They were really nice about what we substituted back in, because really I just have 1.2 minus 4.7 plus 9.62. So when I have stuff like this, I then look at, okay, what would be the best thing maybe for me to simplify down? Like if I try to do these two right now, I'm going to have to like borrow and stuff. But I can reduce that down. What is 1.2 and a negative 4.7? Negative 3.5. So negative 3.5 plus 9.62. So then basically it's just 9.62 minus 3.5, and that's going to give me
6.12. That's the answer. So you can expect decimals on a non-calculator, but they won't be like horrible stuff. Okay. Any questions at all? Grab the next sheet of paper then. This is also going on page 60. So we got a whole lot of stuff going on with example 6. So the graph of f is given to us. A table for g. Here's g in the table. Piecewise function h. And a verbal description of k of x. So k of x says, a k of x is a quadratic function with a horizontal translation of 2, followed by a vertical translation of -3. So I think I want to go ahead and have my equation, just by them telling me that, k of x is equal to, well, if it's x, if I have a horizontal translation of 2, I'd write down x what? -2. And then it's squared because it told me it's a quadratic. And then I have a vertical translation of a -3. Okay, and there's my equation. We're good on that? Easy enough? All right, now let's see what we got to do here. F of g of 7. All right, g, I can get straight from that table there. So that means, what is g of 7? 4. So then I really just want f of 4. Where do I go for that? The graph. And what is f of 4? -1. That's my answer. So you're not going to have to do, like, computation-wise with the numbers, they won't be bad on things like this. They're just seeing, can you read a table? Can you read a graph? Can you read a piecewise? Do you understand what order to do things in? And it's just fairly simple. All right, so I would rewrite this as g of f of 7. All right, so then what is f of 7? 2. So this is now just g of 2. And what is g of 2? 3. Okay. Everybody with me? Then I'm going to rewrite this as h of k of 0. All right. So k of 0, I'm going to find that first. That's going to be 0 minus 2 squared minus 3. So it looks like that's 1, right? So then h of k of 0 really just equals h of 1. H is that piecewise function. These little domains out here tell you which piece you're supposed to be using based on your input. My input is 1. It tells you right here when x equals 1, this is what the function value is. So that answer is -4. Okay. What questions you got? Are we good on where everything's coming from? Okay, then you do D, E, and F. Okay, so I got -3, pi, and -2. We good on those? Beautiful. All right, so let's look at what this can look like on the exam, or some examples of it. Not the only way you would necessarily see it. But on example 7, this table has 2 functions in it, so just be careful when you're pulling numbers out of a table. So it says the table gives us values for f and g at selected values of x. F and g are defined for all real numbers. Let h be defined as f of g of x. So I want h of 1. So h of 1 is going to be equal to f of g of 1. Right? Just substituting in right to where it said it. Gave me that right there. So what is g of 1? 0. So then this becomes f of 0. And what is f of 0? -1. And that's your answer right there. Okay? Just using a table. I mean, sometimes the questions are very basic and very straightforward. Don't overthink them and overanalyze them and make them into something that they're not. Confuse yourself. All right, so then we have f of x, g of x, and I want f of g of x. So f of g of x equals, now here's g, so this is what I'll put in parentheses here, 3x plus 5 squared minus 3 times 3x plus 5 plus 7. So you simplify that down without getting yourself in math jail, because that first thing that you square does not become 9x squared plus 25. While you're doing that, I'm going to hand out your assignment. Should get B. Because again, when you square this, this is what you get. Okay. What questions do we have? Anything? All right.